the motherboard. DAG3BBMBCG0 motherboard, which has to be installed in an HP OMEN 17 laptop. I think it is a i7 7700HQ CPU paired with a GTX 1060 GPU. And yeah, it suffers from liquid damage. So we have already took a small overview. We have many spots of corrosion and liquid damage here on this connector. Then here, this is the DC-in area. This MOSFET has liquid damage. Then we have on the other side, the whole area here has a film of corrosion or damage, liquid damage. Then we have the other side, which doesn't look even better. We have here a film of liquid damage. We have this IC here, this is a small IC, which pretty much suffered from liquid damage. And also the M controller, the Super I/O, has some liquid on it. So I wouldn't even bother to power it on. We have to get rid of this damage first. Let's inspect it under the microscope. So, like before, here on this connector, here's damage. I open it. Here, very green. Okay, doesn't look that bad on a microscope, but it is really, really much corrosion here. Then we have this area, clearly visible damage. Then on the other side, I rotate the board. This whole area here is, I can't even phrase how it looks. But here, this is a good example here. This doesn't look good. Okay, this all has to be clean. Then we have on the other side the Super I/O. Here. A lot of corrosion here. And especially this one here. This looks really bad, this one here. Maybe we need more light, 1 second. Maybe like that. So this I see here. Really dark area around. Now we can look what it is. Yeah, many corrosion. Well, we have to clean this up. I won't power on the board. First we won't get rid of the liquid damage. Okay, so let's go. Looks like there's already a missing part. Not sure. So what do we have here now? Is something missing already? What do you think? Here, it looks something is already missing. Here we have a broken pad, I think so. Oh well, we have to resolder the controller. Yeah. Let's resolder it. I think we have at least 3 pads missing here. I even don't have an idea for what is this controller. I think it's something for the GPU. But we have this pad here is completely gone, and this one too. And on the other side the same. Let's clean it a bit so you can see better. So this pad has to be rebuilt. This one on the other side, and also this one here. Top marking of the controller is 7J, something from the bridge tech. Let's remove it now. We need access to underneath. Oh, maybe. Okay. So what is this? The bottom of the IC. Let's see whether we can remove it. Wow. Welded together. I'm not happy. Okay, I think I have it. Okay. Okay. Wow. This was bad. This was a bad job. Let's remove what is left. So what did I say? 7J, yes? What do you think? Could be worse, no? Let's do some continuity checks. So from this pad to here, open line. So here we have an open line. Here has to be rebuilt. So something else. This looks good. This looks good. Not sure how it is here. This is good. This is good. Here we check again. We had bad contact. No, this is open. This is definitely open. Yeah, okay. So this pad has to be rebuilt. We need a new controller. Yeah, and then we'll see what happens. Not sure what is supposed to be here. So I think we'll continue like that. We'll replace the controller. I have one on one of my donor boards when we'll repair this trace here. And then we'll see what is missing here. I think it could be a resistor because I have the feeling this is the power rail, the input power rail. Let's see. No. Okay. That's fine now. Okay. What do you think? I think we have a bridge here. On this side here. It's a small bridge, I think. Okay. Wonderful. So what now? What now? That's a big question. Now we need some space. Want to prepare my wire. Maybe like that. So now the hard part begins. Let's rotate the board a bit. Like that maybe. Wrong pad. Oh, I think I did it. I think I did it. Okay. Okay. So now well, it could be worse. Could be worse. Where is my... maybe like that. Maybe. Yeah, we cut here. And then we'll have nothing to do when to solder it. No. No. Okay. How does it look? Wonderful, no? So here it is properly soldered, and here on this pad too. So the only thing we know, the only thing we need now is a connection from here to here. And this, let's check. So this pad here is not ground. Let's cross-change the probes again, once again, here. This is kilo ohms. 5 kilo ohms raising. So this is not ground. So this is not a capacitor, which has to be here. Let's take a look at the data sheet. Look here. Pin 18. Pin 18 is a pin in question. This is PVCC, which is an input, supply voltage input, 5 volts. So I'm pretty sure we have to connect a low value resistor there, maybe 1 ohm, something like that. Do we have an example here? Maybe we will find an example here. Okay, 1. What is 1? But a resistor. Maybe 1 ohms. Okay, 1 ohms resistor. This means 1 ohms. This is 2.2. This is 1. 1 ohms. Okay? Okay. So, yeah. I have the Donner board, and it is the same. Back to microscope. Where's my Donner board? Here. So I've stolen the IC from here. Let's zoom a bit out. No. Where is it? Here. I've stolen the IC from here, and here was pin 1, so here's pin 18, and we have here one capacitor, okay, but also this 1 ohms resistor here to the 5 volt supply, probably. Okay, so what we do now is to steal this 1 ohms resistor too and solder it to the board. Okay, just from logical conclusion. Okay. One side. And the other side. Okay. I think we'll remove some solder here, so it will be a bit more nice. Okay. I want to have a small test point. Let's scrape here something. Okay, I think this is good. This is good enough. So let's check again. So here, and we have 2.5, which is okay with the internal resistance of the probes. 2.5, internal resistance is 1.5, so we have exactly 1 ohm, which is wonderful. Good. So now we cover this a bit. Yeah, like that. Okay. So what do you think? Good enough? Looks good to me. Okay. So what with the Super I/O? Could be worse, I guess. It can be the case that we have to remove it to repair traces underneath. However, we'll try without. So what else? This area. This resistor here. This is a current sense resistor, but we have two in series. However, looks burnt, no? This resistor is open line. Okay, we'll remove it. Let's check for replacement before. Wonderful. Okay. Well, I can bring the board back working, but the issue is I cannot speak for all subfunctions. So we have like components here around the USB port and USB-C port and the network port. I just don't know the value, so and schematics are not available, it seems like. So I have no idea what's supposed to be here. No idea. Can try to connect it again, but okay, seems to work. So what else? Here also. I just can try to connect the resistors again and then hope for the best. Okay. This is probably related to sound. think the pad is somehow gone. Okay. Like before, let's remove it. I think I have another one. So how does it look here? There's something left, but it is not much. I think it is better to replace it. So don't be confused. These two here and these two here are together. So there is no issue with we have a bridge here. These are together anyway. So with some luck it is enough. We'll see. So super IO. Let's check for loose pins here. Okay, I think we're done with the repairs. So let's do a small overview. What we have here. Ground. Yes. So what do we have? We have the DC in circuit here. Oh, here. 80 kilo ohms. When we have the area between first and second MOSFET. Once again, 2 mega ohms. When we have the main power rail. $36 kilo ohms. Sounds low. Battery. Kilo ohms. So this is probably for the GPU core. 0.7, okay. Internal resistance is 0.5, okay. It's low, already low. What do we have here? 0.6. What's that? Not sure. This could be an issue here. .45, this is probably for memory of the GPU. VCC system agent, 16 ohms. VCC core, 3.3. VCC GFX, 5.6. It's okay. Memory, 260, this is okay. Probably 3.3 or 5 volts. Same here. Kilo ohms is absolutely fine. 51, this is for the PCH, the one supply for the PCH. So, okay, looks okay so far. For this one, I'm not sure what we have here. What do you think? Are we ready to power it on? Let's see. So plus here. Ground here. Like that. And now? Consumption is 0.008. So I guess the main power rail is present now. So how can we power on the board now? Power button is here, okay. Let's check where our 3.3 is. 2.6, 3.3, 3.3. Oh, we have many 3.3 here. 2.9, 3.3, and nothing. Maybe the last two. I have no idea. Let's check. This two? No. Let's do something else. Let's check which rails have connection to the super arrow. Maybe where are multiple rails, so also no clue. What should we do? I need to know the pinout of the M controller. I need to know the pinout. Okay, what are you? IT8987E. I think I have schematics of a similar device. Here, IT8987E. So, where's the power button? This one? Oh, this one. This one here. 107. So this is pin 1. 32, 64, 96, 100, 107. This one. What's that? Maybe a burnt resistor here. However, let's check for continuity with the connector. Only the second one is beeping, okay. Okay, so yeah, pin 1 and pin 2 are the power button. Okay. Plus, minus, power. And let's see whether we can do something with this one. It just does not react to the power button. It just does not react to the power button. Well, now we have to look for trace damage below the M controller. I see no other way. I see no other way than to look for trace damage underneath the Super I/O. So well, no way to start the board properly. I'm pretty convinced we have liquid damage below the M controller. So we'll remove it now. Anything underneath? Okay. And no liquid. No, I'm disappointed. No liquid. That's bad. That's pretty bad. I was sure we have liquid underneath. But actually, I can't spot anything. Okay, let's clean this mess. So yeah, I can't see any trace damage here. Okay. Let's see where we can save the M controller. Like that, yeah? Okay. So a short rest, and when we'll proceed with putting it back. So let's solder the Super I/O back and see what happens. Okay. Wonderful. Nothing happens. Nothing happens when I press the power button. So another question. It's the HP OMEN. What did I miss? What did I miss before? I missed that it is the HP. So it is not enough to just connect plus and minus, but we have also the adapter detection pins here. Which did I actually miss before? So yeah. We need to figure out how this is supposed to be. Because we have a second connector here. This one here. And one of these 4 pins here is supposed to be for adapter detection. Okay? So we have to reverse engineer this. So for HP devices, the related circuit is called AD, ID. Where is it? Here. On this side, we have the DC jack. When we have a resistor, 100 ohms, when we have another resistor, also we have some other components, but it isn't important right now. And then we have the AD type rail. And the AD type is what connects to the M controller here. Pin 67. Let's see whether it is the same here. Here is pin 67, and when it goes, the rail goes here to this test point, and it goes here to this resistor. This resistor has a value of 2 kilo ohms, which actually fits to our observation. 2 kilo ohms, and then it should go to resistor with 100 ohms. Maybe this one. No, this has also kilo ohms. This one. This one has 100 ohms. This is our resistor. Here we need the proper signal from the charger. So let's go to beep mode and see whether we can find the correct pin, the corresponding pin. Okay, found it. It's the leftmost pin, this one here. This one has continuity with our resistor. Maybe I can show. Yeah, I think I can show here. So this resistor, and now I touch the leftmost pin. This is possible from here. Yeah, and we do have continuity. So yeah, now the magic begins. We have to simulate a HP charger with adapter detection. We have to put a resistor between the charging plus 19 volt and the adapter detection, and then it should be recognized as a powerful HP charger. Let's try it. Now we'll try to connect it here. More solder. Yeah, this is perfect. Okay. So okay. On the other side, we just run a wire. Yeah. Have to remove the coating. Maybe like that. So how can we solder it now? Maybe like that. Wonderful. Okay. So that's our wire. So we'll run it here and here and go straight to this MOSFET here. And now it looks like that. The wire is coated, so no issue here. So yeah, let's check for continuity between the resistor and the plus. Yeah. Zero ohms. This is interesting. We have a low resistance to ground here. However, should be fine. Let's check. In worst case, we just burn the super IO. So plus. Minus. So power. Nothing bad happened right now. Let's check on the bench. Maybe we can start it now. Let's see. No, still no reaction to power button. So we have repaired many components. We have replaced one IC, we have repaired traces of another IC, we have removed the M controller and soldered it back. And we have tricked the adapter detection, and still it doesn't want to turn on. Why? Why is it like that? Okay, my friends, I think it is time to rule out BIOS now. With some luck, it is a corrupted BIOS. lens that. Let's see. With some luck we can do it. No. Okay, read the dump. Looks still somehow intact. Okay, let's solder it back quickly and hope for the best. Okay, camera was stack. Let's see whether the device works. Okay. Okay, let's short the pins at the connector. Oh, come on, it is coming on. I can't believe. Okay, let's stop it. It was BIOS issue. I can't believe. Okay, let me grab some memory. Okay, let's see whether we can picture out of this one. Maybe caps lock, something like that. I'm not sure whether this USB port does work. Maybe we have to replace the filter there. Okay. So let's short pins together. Okay, it's coming on. HDMI is not switching. I'll check caps lock. Okay, power off, power on. We'll be patient. I think the CPU is working. However, I think the keyboard does not work. Let's check with this one here. Oh, we have picture, we have picture, we have picture. Let's show you. It is done. We have picture. Wonderful. This is wonderful. Great news. So now we have to. So now we have to look. Yeah, what we can do here. Now it just shuts down. Oh, not bad. Not bad. Okay. Okay. So as always, thank you for watching. This was one of my hardest repairs ever. However, it is fixed. We have picture, and now I install it with Windows and see whether we have to sort out something. But the basic is done. Oh, my friends, I am so disappointed about this board. It is so sad. Well, I was able to install Windows and everything was fine so far. But as soon as I installed the drivers for the graphics for the 1060, I immediately got a black screen, and yeah, that's it. I was able to access the device via TeamViewer, and yeah, immediately noticed the code 43 for the GPU, so there is an issue, and yeah, it is most likely gone. I've checked and compared the various power rails, the GPU core. This is something like a secondary core, NVVDDS. However, also here we have the VRAM, and here we have a small load switch for PEX, and everything is working. Everything is inside of the specs. I've also tried Mods, the NVIDIA test suite, and yeah, nothing turned out. No, so no bad memory banks or similar. Everything was fine there. And yeah, it seems like that's it. So I get picture from this one, and it is still working, but the dedicated GPU is gone, unfortunately. So in the end, it is a no fix. So I just wanted to inform you, because I don't want to lie to you. So this is a YouTube channel where I'm used to tell the truth. There's no magic, no miracles in electronics. It is just these devices can die very easily. Okay? So, however, thank you for watching and for your great support. I think in my next video I'll show a tutorial how to program M controller without schematics, without everything, with a Vertjenov jig. And yeah, I hope it will be interesting for you. Thank you. Bye.